We are live. A very good afternoon, one and all joined in this virtual platform. It is our privilege to host you all for the release of Indian Bipv Report 2022 Status and Roadmap. With this, I invite Dr. Unni for welcome address. Over to you, sir.
Thank you, Adarsh. So, respected Director CSR NIST, CSR NCL, and Director of SUBSI, Dr. Roman Rudel, other distinguished invitees, dear colleagues, ladies and gentlemen. So, as I mentioned in the morning, we are having this Azadi Ka Amrit Mahotsav, which is the celebration of the 75th anniversary of Indian independence. And the Ministry of Science and Technology and Ministry of Earth Science of Government of India have come together with this program called iConnect, in which 75 events are being organized for better handholding, increased interaction with industry. So in this connection, I'm very happy to see that out of these 75 programs, 11 are coming from the energy vertical of CSIR. And CSIR NIST, National Institute for Interdisciplinary Science and Technology, is organizing 2 of the events. So in the morning, we had 1 event, and in the afternoon, now we are having the second event on building integrated photovoltaics, which is also organized by CSIR NIST. So we are the nodal lab for the energy conversion and related devices vertical under the energy theme. And we have 14 CSIR labs participating with us in this sub-vertical. And we work on photovoltaics, thermoelectrics, photovoltaic allied technologies, piezoelectrics, and many energy generation and energy conservation technologies. We are thankful to the organizers of the iConnect program for having selected 2 of our proposals for these 75 events. Now, with this introduction about the program, it is my great pleasure to welcome all of you to this session. Dr. Ashish Lele, Director CSIR NIST, and also Director National Chemical Lab in NCL. He has kindly agreed to inaugurate this event. Again, for an energy-related event, we cannot find a better person suitable for inaugurating this event. His research interests are more or less aligned with the energy-related activities, smart hydrogels, polymers, and advanced materials. His current interests are end-to-end hydrogen value chain with detailed knowledge and techno-economics, business opportunities, and technology advances in fuel cells for mobility, power, and heating applications, deep understanding of the fundamental science behind transport phenomena, and reaction engineering in polymer electrolyte membrane fuel cells. So you can see that his research interests are more into energy-related activities. And on behalf of all the organizers of this event, let me offer a hearty welcome to Professor Ashish Lele, Director CSIR NIST, to this event. Welcome, sir. Also, this event is inaugurated by Dr. Roman Rudel, who is Director, ISAC SUBSI. He has kindly consented to be present during this event. He is the Director of Institute of Applied Sustainability and Built Environment at the University of Applied Sciences and Arts of Southern Switzerland, or SUBSI. He is an active presence in technological, social, and institutional innovations with an environmental relevance. So SUBSI is also a partner with the CSIR NIST as per an MOU signed in 2019 for research collaboration on energy. And we have many important delegates attending from industries. Masiba Philip Topsu, class features, Dr. Berliogi Bonomo, Head of Advanced Building Skin Team, Swiss BIPV Competence Center, ISAC SUBSI. Mr. Paulo Corti, Researcher, Advanced Building Skin Team, Swiss BIPV Competence Center. Architect Anand Sabu, Director Megajoules and Founder Sahyog Designway Private Limited. Mr. Pashupati Gopalan, Co-Chairman and CEO, Standardization. Mr. Jinder Joseph, AGM, Topson Energy Limited. Dr. Jaiprakash Singh, Director, National Institute of Solar Energy, NICE, Ministry of New and Renewable Energy, MNRE. So, let me welcome all the distinguished delegates to this inaugural this session of building integrated photovoltaic activities. I hope this will provide a platform for discussions, future collaborations, and all efforts to further this technologically important area. With these words, I welcome all of you to this function. Thank you. Now we have the inaugural proceedings for the BIPV status report should be released. So that is a major part of the inaugural function of the program. This is a massive report prepared looking at various economical, technological aspects of building integrated photovoltaics. And this is a project done between SUBSI and the CSIR NIST. Dr. Adarsh Ashok, who is a scientist with the CSIR NIST, has been the backbone of this activity. He has put in tremendous effort to bring out this report. And the first 3 chapters of this report has already been released on public media. And we have received very, very encouraging reviews of these reports. So today, as part of this iConnect event, we will be releasing the entire report. And I would request Dr. Adarsh to take over and continue with the proceedings of the release of Indian BIPV report 2022 status and roadmap. Over to you, Adarsh.
Thank you, Dr. Unni. Now I welcome the Director, CSIR NIST, Dr. Ashish Lele, for the inaugural address.
Thank you, Dr. Adarsh, and thank you, Dr. Unni, for inviting me to this very important event today. Unfortunately, I am not going to be able to stay for the whole event. I stayed practically through the event in the morning session. In the afternoon, unfortunately, I won't be able to stay. The only reason being that, I think India is such a happening place for renewable energy today that almost everybody in the world is looking at partnerships, of course, with each other, but also particularly with India. And in the afternoon, just in under 15 minutes, I have another such event with Australia, a joint collaborative event on clean energy with Australia. And so I can't be at 2 places at the same time. And so I thought I will spend some time here and then spend some time there as well. So you'll have to forgive me for this event for not being able to attend it fully. But as I said, India is really and truly going to be the bedrock of innovations and deployment of innovations in the renewable energy sector. In this country, we have an incredible opportunity for doing energy transition by leapfrogging and not really following what other countries have done. We are a very aspiring country, a young country, and our energy needs will clearly rise in the future. If we even follow the standard chart of energy consumption per capita versus GDP per capita, almost every country seems to fall on a master curve. And we are at the sort of lower end of that master curve. And as the country progresses and as we climb along this master curve, we have the opportunity to do so without hurting climate, without going through the same process of emissions that other countries have unfortunately had to follow. So it's a wonderful opportunity for India to leapfrog. We are also blessed with a substantial amount of sunshine. We are blessed with a lot of water. It's the only question of managing the water resource. There is no dearth of water resource, honestly, if we can only manage it. So primary sources of energies such as sunlight, water, and so on, wind, are available in this country. So therefore, there is even greater opportunity for India to progress along the renewable energy front in order to support our growth in economy. We, of course, have a very ambitious program, a plan of reaching $5 trillion economy in a very short time span. And by that time span, it is estimated that India will consume about 28,000 terawatt hours of primary energy. And if we go by the announcements made by the country today, about 5,800 terawatt hours are likely to come from renewable energy. And if we do things right, another 2,500 terawatt hours will likely come from bioenergy. There will be a smaller addition to through nuclear and so on. So in all of this, there is a huge opportunity for India to bring in the latest technologies to support this growth in renewable energy. I think one of the things that is pointed out in this report, and I have only read the summary of it, I'm more than looking forward to reading the full report. But what I have noticed, and very rightly so, is that the era of centralized energy generation is going to be behind us, and we are going to be focusing more and more on decentralized energy generation, because the whole source of primary energy is going to be different when it comes to wind and solar and biomass and so on. These are naturally abundant everywhere across the country, and not in a few mines or a few places. So the thermal power plants are going to be replaced by decentralized power generation sources, whether it is wind farms or solar and so on. And as we drill it down, the decentralization, drilling it down to even at building level, that's where the BIPV would come in a very big way. In fact, India has a huge capacity for solar rooftop, and we haven't even scratched the surface of solar rooftop. That is one immediate source of decentralized power generation. But going forward, I think BIPV is likely to be another very major source of renewable decentralized energy generation. I must also add that, for several reasons, India has today fortunately grown a massive digital infrastructure. And that's another decentralized platform for technology development and technology scale up that is available at incredibly low prices across the country. And those who come to India will realize how low prices are for any digital application that one uses. And this would provide, when this is coupled with decentralized power generation, I think it's a very, very unique opportunity that we have in the country. So a BIPV supported by digital would be a very interesting solution for urban cities, which, as we also discussed in the morning, are growing vertical. Whether we like it or not, in all the metros in India today, we are increasingly going for glass facade buildings. We then worry about what do we do with all that heat and light that is coming inside the building, and then we go with centralized air conditioning and then worry about what do we do with the CO2 emissions. So it's sort of a vicious cycle that we don't want to get into, and therefore, if we can harness all that light and heat that is coming in and use it for the purposes of generating renewable energy, utilizing the heat that comes with it, I think that's the kind of opportunities we have. In terms of technology, the challenge, of course, is that the maturity of those technologies is not at the level where silicon solar PV is. The deployment is certainly not at that level. The economics may not look very exciting as of now, but I think it's a matter of scale up. And again, I would say that India offers that opportunity for immense scale up. If we can build those end-to-end ecosystem for renewable decentralized energy generation within the country, and the scale at which we need it would bring the economics, make them much more viable and attractive. So I would say that BIPV would be very exciting for India. I think there is immense future here. We only have to think of how do we bring the entire value chain in the country. How do we make the materials that go into BIPV? How do we make available the manufacturing facilities in India where large scale BIPV devices can be manufactured and deployed in the country. So right from manufacturing the chemicals to coating them on various substrates such as glass and converting them into products or devices which can be then deployed in buildings would be the entire value chain, which I think would be worth bringing all aspects of it in this country. And with the scale of chemicals manufacturing in India, and also the new technologies for chemical manufacturing in India, we should also be ambitious to become a global supplier of some of these important raw materials that go into making BIPV devices. So I think that is how I would look at building BIPV applications and deployment in India. And I look forward to hearing maybe a recording of these deliberations, although I can't attend it in person. I would, Dr. Unni, if you can share with me a link for the recording, I would certainly like to go back tonight and have a look at it. Yeah.
Sure.
Yeah. Thank you so much for inviting me again. And I will look forward and wish you all the success for this event. I also want to thank Dr. Roman Rudel from Switzerland and all his colleagues who are here today. And I'm sure they are going to present some very exciting developments that I will go back and listen to in the evening. So thank you so much.
Thank you, Dr. Atishle, for your insightful inaugural address. With this, I welcome the director of our partnering institute, SUBSI ISAC, Dr. Roman Rudel, for the inaugural address. Over to you, sir. Dr. Roman. Yeah. Yeah.
Can you hear me?
Yeah, you're audible.
I'm very sorry, but my battery was just running out of charge, and I had to find a new battery charger. Sorry for that. I'm not in my office. So could you please show my slide so I can start with my short talk? And of course, I can already start with my speech, and I would like to say that it's a great pleasure for me, for us, to participate in this special event for the presentation of the release of the Indian BIPV report. And it's also a great honor to have contributed, of course, in the person of Pierluigi Bonomo and Paolo Corti in this document with our expertise. I would say that we have quite a long history in BIPV, and Switzerland is somehow a special niche market, and we are leading in a certain way and we are leaders in Switzerland in this market. So we are very have a long story in the BIPV, and we are very proud and happy to bring our knowledge also to India. Since our last visit in India in 2019, when we started our collaboration, of course, a lot of things has happened, and I think you also achieved, as we see in this report, quite a lot of impressive BIPV buildings, and of course this is a great pleasure. Nevertheless, I think, as was said also by Professor Arish Lele, whom I would like to thank for this invitation, that we have to accelerate, and it's really urgent to pass from this from fossil fuels to renewables. However, it's a little bit strange that in the present situation in Europe, we are now very much focused on short-term problems like the energy crisis coming up for the next winter. So we are losing a bit this picture of this energy transition. And I would like to just to highlight with a few pictures and a few thoughts about that, and remind us of the larger picture, as had also been mentioned by Professor Lele, that we are really in the middle or in the starting phase, let's say, in a very important and very profound transition from central power plants to decentralized powers, from fossil fuels to renewable resources, from separated sectors like mobility, households, energy generation, to a sector coupling with a strong electrification. So the grid, of course, the electrical grid plays a fundamental role in this transition, and the management of the grid, of course, will change very profoundly from centralized control to decentralized control, where also we try to bring our expertise in all the debate.
Dr. Roman?
Others, there is some connection problem. I'm trying to contact him.
Okay, permission.
Sorry for that. Unfortunately, connection is not so good. So as we were saying also, Professor Lele, that in this transition, we really also go from separated sectors like mobility, households, energy generation, to a sector coupling with strong electrification, where, of course, the grid becomes a new role, a central role, and the management of the grid, the so-called smart grid, becomes a crucial element in this transition. Moreover, we also shift from large and concentrated investments to a more democratic, let's say, investment landscape with a large citizen participation. And I think this is a great opportunity, and this also helps, of course, to arise in cities a new awareness about energy. And this is even underlined with the shift from also separation of producers and consumers to the so-called prosumers, which is a new word, a new term we more and more use. And I think we do not even yet understand the meaning of what this means, this transition to the prosumers, where persons and people really are participating in the production of their own energy and the consumption of their really bringing their awareness for energy and energy-related topics to a new level. Of course, this transition, and please, we can shift to the next slide. This is not so an easy process. Now, you have the ambition in India to make a leapfrog, but even when you want to make a leapfrog, the process is not so smooth. And I just wanted to remind you with this slide from a rather interesting multi-level socio-technical transition process from this approach, which becomes more and more popular also in Europe and the United States, that there is really a multi-level and multi-actor landscape involved in this transition. And it's not so easy that every technical innovation will then also succeed in the market. I don't want to go deeper in this, but just to remind, it is really a complex puzzle, and you have to bring a lot of elements together that really make them also this transition successful. And we can say with the next slide that, for example, in the EV electric vehicle sector, we had this kind of success, and we have also reached the so-called tipping point where there is no return on this development. And this is normally accepted that this is about 5% of the new sales of in markets where you have more than 5% of EV cells, you have reached this tipping point, and this will then strongly accelerate this process and help to shift to this to the new situation. Now, in BIPV, I don't think that we can say already that we have reached the tipping point, but of course, with the release, and then this is my last slide, with the release of this important status report, and which gives also a roadmap on BIPV in India, I think we have reached an important point in this transition, and I hope that we briefly soon can show that this is also demonstrated with a market share where we can say now BIPV has reached the tipping point in India. So I think it's really important that we have this status report, and I'm very, very proud and very honored really to have participated in this report, and also of course I'm very curious about the reaction of the public, and in particular also of the Indian industry. And we are also ready, of course, to participate in further research, further support to accelerate and to really help to leapfrog in the renewable energy area in India. So thank you very much for your attention, and sorry for these short technical problems with connection to India. I would like also to wish you a successful event, and hope that there will be a lot of reaction and a lot of new ideas coming out of this meeting. Thank you very much.
Thank you, Professor Roman, for that wonderful presentation. In fact, I would like to assure you that the reactions so far, what we have received for the first 3 chapters released online, are very, very encouraging. So we wanted to assure you that it is well taken by the public, industry, and other stakeholders. And now I would request Dr. Adarsh Ashok to continue with the proceedings of the release of Indian BIPV report 2022 status and roadmap. Adarsh.
Thank you, Dr. Unni. With the inaugural address from directors from CSIR and IST, Dr. Ashish Le, and Isaac Subsi, Dr. Roman Roder, and with their kind permission, I'm flashing the QR code connecting the link for downloading the Indian BIPV status report 2022. It will be down. We can scan this QR code and download, and request both the directors to officially announce that the report is released.
Adarsh, very happy to say that the report is released. Thank you.
Thank you, sir. Dr. Roman.
Dr. Roman, you may kindly declare that the report is released.
Okay, I kindly declare that the report is released. Of course, also on behalf of our Indian colleagues and of Professor Ashish Lele.
Thank you very much. Others, we can continue with the presentations.
So with this, we will move on to the briefing section of this report. I will give a brief of the status report. It is my privilege and pleasure to brief this Indian BIPV report on behalf of Indian BIPV at Indo-Swiss BIPV team. And the report has 4 chapters and discussing the photovoltaic sector and its potential in India, and solar construction, BIPV roadmap, and finally we will touch upon the case studies and case study analysis of different BIPV installation and their potential. Moving on to the first chapter, focus on the PV sector potential and market growth. The highlights here are, as per the MNRE, our estimated solar potential is similar to 748 gigawatt. However, the integration of PV into building will enable us to extend this potential far beyond a terawatt energy ambition that we are looking forward, which highlights the importance of BIPV implementation in the country. And as you all gathered here, will appreciate that this is a need of our considering the decentralization of electric power and has come up in more significant in this era of electric vehicle penetration into our transportation sector. And now our solar PV tariff, if you notice here, we have met a record reduction of similar to 2 INR per kilowatt hour, marking the effect of solar national mission. This section reiterates the evolution of PV sector in the country with a few milestones for its adoption in the building sector, making huge potential for solar adoption in the building sector. The first chapter also discusses on the renewable power sector of India and financial scheme for the existing building solar scheme in India. Chapter also compare the global acceptability of rooftop installation. This slide shows the second chapter, majorly discussing on the green building revolution in the country, where we are making use of GRIHA standards, and the role of BIPV in improving GRIHA rating is deliberated here. And this highlighted that BIPV can involve in more than 60% of essential criteria listed by GRIHA rating, thereby helping the green energy revolution in the country. As you can notice here in this section, they discuss the classification of BIPV, different BIPV element and BIPV, and we have also tried to define the BIPV and discuss the application of BIPV elements adopted for building scheme. The section is expected to avoid ambiguity that is all existing in the case of BIPV definition. Where we have also covered the solar potential analysis of the different region. As you can see that in the chapter here, we can see the BIPV score that we have come up with. And the interesting fact that I have to note down here is in the southern region of India, in Thiruvananthapuram, the orientation between east to southeast rather is having more BIP potential than facing south as a regular rooftop installation done. And this more details you can find it in our report because this will be an important point for the policy makers to think more seriously about considering vertical installation for including in the financial schemes further. In the 9th chapter, here you can see that in the 3rd chapter, where in this chapter we have focused on 5 factual contemplation level to initiate and define a collective and concrete roadmap for BIPV implementation in the country. This includes government policies, initiatives and business models, multifunctionality and cost reduction, technology readiness, both on the supply chain and certification requirements, And innovation landscape, basically we focus on the research projects and engagement of international community, which is a prerequisite for getting different BIPV product segments into the country as such. And we also define the stakeholder involvement, the need for stakeholder awareness for basically for extensive project planning and execution is also a must for BIPV implementation in the country. So in the right side, we have defined the stakeholder map for from our analysis that we have done throughout this report. Here, the fourth and the final chapter, we have included a few representative case studies to analyze the BIPV sector and its installation in the country. Basically, it will highlight the potential of BIPV as such in the country, and the awareness is getting in a larger way, but favorable policies will take it forward to more fruitful outcome in the near future. Here, I would like to introduce our Industries BIPV team behind this report. With this, I am winding up the report briefing. More details you can find in the QR the link that I have shared during the release. And on behalf of Industries BIPV team, we thank all the attendees, and we strongly hope that Indian Sun will shape its billing in the years to come. With this, I'm handing over to Dr. Unni for the further proceedings. Thank you all.
Thank you, Adarsh. So that has given the content of the BIPV status report in a nutshell very nicely in a few slides. But I would like to request all the participants to download the report and go through it. In fact, I wanted to ask one question to Dr. Adarsh and particularly to his counterparts in SUBSI. Normally, such reports cost a fortune, and why are you giving it for free?
The basic idea is to, I will start with my point. Basic idea is to promote the awareness among the different stakeholders. So that was a basic motivation for us to make it free. And I will request that I request Dr. Palluji to add up on further.
Adarsh, I mean, I perfectly agree with you, with what you just said. I confirm that the awareness creation and the transfer of first investigation about the BIPV market potential was the aim of this first report. And yeah, I would say as a precursor of possible next steps. So we are really interested in getting feedbacks and reaction from real actors from the value chain about what we said in the report.
Thank you, Professor Bonomo. So the next presentation is by Dr. Pierluigi Bonomo, Head of Advanced Building Skin Team, Swiss BIPV Competence Center, iCEN-74. He will be talking on BIPV market status and potential in the European Union, BIPV research frontiers, BIPV challenges, and way forward. So over to you, Dr. Bonomo.
Thanks a lot, Dr. Unni, for the kind introduction. Okay, I hope that you can correctly see the screen. So,
yes.
Thanks a lot. And I mean, first of all, I want also to say thank you to the Council of Scientific and Industrial Research of India, and in particular to NIIST Institute for the collaboration and also for involving our research group in this iconic event today. I am also personally really proud and honored today to present a brief snapshot on the status of the European and Swiss market about building integrated photovoltaics. And so I will try to provide some main highlights about situation and also providing some outlooks on the research potentials about this topic. So, I mean, briefly, I will try to cover these 3 points. So I will start by briefly describing a couple of features about the market status and also the main potentials. Then I will also shift on some key questions concerning research in building integrated photovoltaics. And I would like to conclude also by reporting some key challenges that we highlight as key ideas, at least in European and Swiss context, to go forward in this sector. So about the market in Europe, I started with this picture, which is a picture I took in our campus, in our SUPSI campus, and it's reported a very small exhibition that we host and we installed in this period. And the title is in Italian, but it simply reports the topic of solar energy as a building material. So this is the storytelling of this small exhibition, where, as you can see, we put some real samples since 1982 till today, some real technology pieces of photovoltaics for buildings, and we also tried to report a story through real case studies. So this is just to say, just to introduce also the history of our institute, which was born in 1982 with this first PV plant grid connected in Europe, and to say that also build integrated photovoltaics has a 40 years history in Europe, since the first installation to these different ages of evolution of the technology. And in this long evolution, we cross different ages and approaches of technology transfer in building sector. And we also decided a few years ago to shift the wording and the approach from a merely technological approach to the word solar architecture. So to really highlight that more and more it's relevant to address the construction field and the architect's needs with photovoltaic technology. And I reported here the reference platform for solar architecture that we set up some time ago with the collaboration of ETH and Tree Solar. And I invite all of you in taking a look to this website, because you can find all the last examples, realized examples where PV technology is used and implemented as a real building skin material. So what to say, I won't go across all these numbers, but I reported this slide just to argument that Bipv is studied and analyzed since at least 20 or 25 years in Europe, from the International Energy Agency to all the research actions and projects. But in terms of number, we have to say that it's still a niche market, and it's just deployed a small percentage of the available potentials in Europe and in Switzerland. But on the other hand, from an optimistic point of view, we can also say that in Europe we had a very fruitful development period, since we have available on the market more than 200 products today, and also more than half of the installed capacity today is in European area. Of course, I mean, the market trend, we all know this trend, because Bipv as PV, as conventional PV plants, was pretty related to supporting measures. So we all know this curve of development, and also then the decrease of the market in the coming years. But I mean, this is also in our opinion, the indicator that favorable support measures for conventional PV are not necessarily adapted for building integrated photovoltaics. This means that in BIPV we have really to address some structural barriers related to the construction sector and to the engagement of building stakeholders. I will try to come back later on these topics. I just want to add that also in Europe, the framework and in Switzerland as well, the general political framework is really favorable, and it's practically improving the case for BIPV today. At European level, we have a lot of initiatives, and just to mention Green Deal and Renovation Wave, which are really a huge strategy, which are really highlighting the need of implementing BIPV and of joining construction challenges such as renovation with active building schemes. So what's the role of research in this framework, and at least what is our activity, which are the main activities of SUPSI and of our research group in this framework? And I started with this slide, which already presents the results of these activities, since we can say that a very strong relation between applied research and industry and market during the recent and the past years brought to ready product on the market today. So today we can rely on multifunctional products ready for the marketing and for the real implementation in building scene. And I just reported here some Swiss example just to show and to provide the evidence that we managed to address a really huge portfolio of different and flexible solutions. So from a research perspective, so if I focus a little bit on my role and on the research team role, I can easily say that our approach is really a very applied research and a very practice-oriented approach of research. And I briefly summarize in this slide the level of technological readiness that we usually comply with. And so we basically start from a multifunctional component validation to bring step by step the technology towards the market. So key steps of this transfer process are the validation and the qualification of products. And we have a PV testing lab at SUPSI for providing indoor testing, qualification and assessment of the technologies. But we more and more work at a real scale level. So we are very and more focused on real scale mockups where we can observe and test technology in real operating conditions. And last but not least, in pilot projects. This is a key step for assessing the technology in a real building scale and in operational environment. So just an example, we had the possibility to work in several multidisciplinary consortiums during last years at European and at Swiss level. This is just one example of a European project funded under the Horizon 2020 program. The project is almost finalized today. We are realizing the real building demo case in this period. But just to report, as a research project started from very practical market needs, and namely from a cost reduction target. So here a European set plan defined 50 and 75% of cost reduction target to demonstrate for multifunctional products within within the project duration and also for the coming years. We managed to develop such a portfolio of building scheme systems to test and validate the system and also to realize demo cases. So this, of course, involved a lot of teamwork and combined efforts between research and industry. So just in this slide, the main industrial partners of the project. And so, as I briefly mentioned before, our role as a research institute to validate the technology and to demonstrate its applicability on a real scale level. So in this case, we developed different roof and facade systems and also a balustrade technology. But I don't want to go in detail now about this. I just want to conclude this part just saying that pilot projects are a key part of this technology validation. So more and more we are working with real architects and real players of the value chain to construct buildings with active facades. Just a few examples here, but my colleague Paolo Corti will briefly report about one specific projects. So how to summarize, how to sum up the challenges of Bipv, and I mean, this would be quite ambitious expected goal, but I will try grouping 4 main key aspects of mapping the main challenges that we believe are the key drivers for implementing this technology on the market. So first of all, the industry, the manufacturing. Here, of course, it's needed to combine standardization and customization, which are the 2 trends which Bipv needs to put together and to optimize. On the other hand, products needs to be implemented on the market. And here it's crucial, the topic of certification of the products. In Europe and in Switzerland, we know very well this topic. We are working very deeply in defining new testing procedure and new methodologies, because basically Bipv is a multifunctional technology. So we really need to bridge together the construction world and the photovoltaic and electrotechnical world. So this is more and more important. I just finished with the other 2 ways forward that I would like to list today. So technology is the starting point, but as Dr. Rudel said at the beginning, we need also to favor the real impact on the market. So this means that cost competitiveness is a key challenge for implementing in building sector Bipv, and also creating knowledge. So creating new skills among professionals is a key challenge for us to ensure this technology evolution. I just conclude with a thank you to the working group of this status report, because I think we addressed a specific topic like building integrated photovoltaics, and we also tried to draw up the roadmap for this technology. We are really glad that we had the possibility of learning some first perspective about the Indian context, and we really would like, and I would say that we are really committed and interested to foster this strong Bipv implementation in India. And I'm really proud that our group, which met in 2019 and exchanged this memorandum of understanding, today managed to realize this first milestone and report. So yeah, I want to thank especially my colleagues Paolo and Adarsh and Animesh for the great job. Thank you very much, everyone, for your attention.
Thank you, Pierluigi, for briefly touching upon the go-to-market strategies and how Subsea can support on that aspect. It is very interesting that some of the pilots you are. I think we will be getting more details from Paulo's presentation. So with this, I am going to our next speaker, Dr. Narayan Unni. Dr. Narayan Unni is our CSIR Energy Conversion Vertical Lead, and he is a Senior Principal Scientist at Photoscience and Photonics Division of CSIR National Institute of Interdisciplinary Science and Technology. With this, I request Dr. Unni to share his presentation and take over.
Thank you, Adarsh. The slides are visible?
Yes, yes.
Okay. So once again, good afternoon all. I am Dr. Narayan Unni. I am presenting on the solar energy activities at CSIR, a Bipv perspective. In fact, CSIR has many activities in the vertical energy, but energy conversion, energy conservation, energy management, all these things are given sub-vertical. So we at CSIR NIST are coordinating the activities on the energy conversion and the related devices, wherein we work on building integrated photovoltaics also. So these are the activities at a glance, because this data is collected from several CSIR labs. I will not be going into details of each of these, but I thought rather I would give a glimpse of the activities which are happening at the various CSIR labs. So we have 14 CSIR labs working with us, and each have their own mandate and they have their choice of different areas. But power generating windows, that is dynamic power windows, and the large area module fabrication systems, mostly for the third generation photovoltaics, light concentration techniques for silicon to enhance the power conversion efficiency of silicon solar panels, rooftop agrivoltaic systems, building integrated solar water heater, solar metrology, solar powered electric vehicle charging stations, and of course, we do quite a lot of work on fundamental side with novel materials and device designs. The first one is the dynamic power window technology, DPW, developed at CSIR NIST. Dynamic power window is in a way first of its kind CSIR technology. This is an innovation that can integrate both energy efficiency and clean energy generation using a single platform. So the patent is filed for this invention. This in fact has multi-channels within the glass structure, where with the application of a liquid and index matching, you can have two states. One is a transparent state and the other is the opaque state. That normally happens with any dynamic window. But the addition here is that with the suitable application of optics, like you can see in the window, when solar flux is exposed to this glass, it is concentrated on the edges here. And if you can keep a solar panel at the edge, you will be able to generate much more power, because your for silicon solar panel, you know that when the concentration of the solar flux increases, then your power output increases. So with minimal amount of usage of silicon solar panel, we will be able to generate a lot of electricity. So that is the idea behind this particular concept. And the peak power tunable from 100 watt peak to 300 watt peak from typically an area of 2 meter square window. But it depends on the kind of transparency that you require and the cell efficiency, because solar cell also, you know that there are different efficiency values for monocrystalline and polycrystalline thin film solar cell like that. So whichever you choose to be incorporated on your window, depending upon that, the power peak power will be slightly varying. And the transparency switching solar reflection is there. So you can have solar heat gain control and you can have solar light diffusion for daylighting. So this is a concept which is shown here. This is a technology adaptable for transparent glass Bipv modules, where the solar light with a diffused rendition you see here, you can use it as the indoor lighting also. Now, The next one is the DSSC module fabrication facility for building integrated photovoltaic and indoor photovoltaic at CSIR NIST. We had a project funded by Department of Science and Technology, Government of India. This project was selected in high priority implementation category by Prime Minister's Office, Government of India, wherein first time we developed equipments, in fact, a range of equipment which are required for fabricating large area solar modules. You can see that we can go up to 30 centimeter by 30 centimeter DSSC panels. And with the chemistry that we know, because National Institute for Interdisciplinary Science and Technology traditionally has expertise in photochemistry, photophysics, material physics, material chemistry. So with that, we can actually tune the properties of the dyes that are used in these solar cells. You can have different colors. So not only power generation, but an angle of aesthetics also can be incorporated into these windows. So these are some of the equipments that we fabricated here. The interesting thing is that earlier people used to import these equipments, but with this project, whatever we could do is that we could in fact demonstrate that these equipments could be made in India with a cost reduction of 50 to 60% compared to what we used to import. So all the process starting from glass cutting, screen printing, silver dispensing, annealing, die coating, hole drilling, UV dispensing, UV curing and electrolyte filling. All these are now done in a semi-automatic fashion, and the facility is here. So whenever any one of you for a conference or for a personal visit, when you come to Trivandrum, I would extend an invitation to visit the CSIR and NIST and see these facilities because it is first of its kind in India. Dr. Suraj will give more details about the DSSC fabrication facility because there is another talk coming up, so I will not spend more time on that. Now, the third one is the light concentration photovoltaics, CPV. This also at CSIR NIST, we have developed planar light concentrating optics elements, which can give a 5 times concentrated solar flux and also with a high solar acceptance angle. Normally, we know that so concentrators are there, but the solar acceptance angle is not great. But in our case, with suitable optics and modification of the microstructural design within the panels, we can have higher solar acceptance angle, and it can be easily adopted for Bipv architectural facades and all. And see here, an example is given here. Whatever solar flux is incident on this will be concentrated again to the edges because of the optical design. And with that, you can see this fan is running. And also, again, you can have colored solar tiles. It's not only the normal transparent in nature, but other than that, you can incorporate pigments or polymeric materials into this, and you can have different colors. Again, as I mentioned, not only energy generation, but it can have an artistic or aesthetic angle also. And with that, you can control the transmission. You can see that each of these, in fact, each of the edges here, these junctions, there are solar panels. We don't see that, they are hidden. But at the same time, you can tune or design these panels so that you can have a particular wavelength which will be allowed to transmit. So that is the color that is shown on the ground. So this, in fact, on an ideal level, it is proven at CSIR and NIST, but it's a long way to go. In fact, there's a lot of ramifications in building design and construction of facades. Another important activity from CSIR and NIST is rooftop agrivoltaics at CSIR and NIST. As we all know, agrivoltaics is also getting a lot of momentum nowadays. There's a program by Government of India called PM Kusum. Kusum is Kisan Suraksha Evam Urja Yojana. So that is what is the program for increasing the yield of farming along with generation of energy. So in Hindi, we say Annadada, who is a farmer who provides food, he will become Urja Dada also. Urja Dada means who provides energy. And agrivoltaic is there for some time, but simply planting solar panels in fields, for example, will just lead to solar desertification only, because you cannot keep anything under that. It is only a shady area. But with our innovation, now we can control the transmission. Diffuse optics is possible, so you can have certain plants which can have low lighting conditions. And in fact, this is very good also, because when you control the incident light, sometimes leafy vegetables like lettuce and all, their leaves will become larger to absorb more light energy. So that increases the yield of the cultivation also. Along with that, you can generate power. So that is the idea behind rooftop, agrivoltaics coupled with optics. And then immediately the application is that it can go to rooftop. Instead of having solar panels on your rooftop, if you use this rooftop integrated with agrivoltaics, then you can have your cultivation also, agriculture also on the rooftop. And it can have different manifestations. It can be horizontal, it can be vertical with a large acceptance angle, and all things are possible. And the solar potential analysis of buildings and building information models, also we are working on that, particularly for BIPV elements. And we can make it available for individuals, business, and government agencies. So that kind of a modeling studies and providing a feasibility reports, all these are possible with the current expertise available at CSIR and IST. Now, CBRI, Central Building Research Institute, another constituent lab of CSIR, they have an activity on efficient flat plate solar water heater. Solar water heater, again, it is already there. But the innovation here is that the scientists at CSIR CBRI are using double glazed solar collector here. With that, they can control the efficiency, the highest efficiency. For example, when the plate temperature is at 100 degrees Celsius, the efficiency is 60%. The industry standard is around 30% only at the moment at that high temperature, 100 degrees Celsius. And the working principle is simply the convection hot water collected in tank through natural convection. The important features are, as I mentioned, there is a double transparent glass cover is used to reduce the convection losses. Heat loss coefficient of double glaze collector is much lower than the heat loss coefficient of single glazed collector. So that is the innovative element behind this realization of this solar water heater. And they have the expertise in doing the numerical modeling and the heat distribution. All those things can be done. CSIR, CSIO, Central Scientific Instrumentation Organization, as the name indicates, they are good in designing and developing equipment. So along with that, there is an activity on designing and developing of equipments which are required for photovoltaic, and also in particular for building integrated photovoltaic. PV elements are becoming an integral part of the building. Already Professor Roman was mentioning that we are at the tipping point, 5 to 10% adoption is there, then that means the technology is ready to be adopted by the general public. So we believe that at that time there will be a requirement of all these equipments, inverters, and all other things. So CSIO, a constituent lab of CSIR, is ready with such expertise. They have measuring devices in testing and evaluating the performance of both grid connected and off-grid solar photovoltaic systems. It can be installed in buildings and industries. And they also propose to develop a solar photovoltaic performance analyzer to be used for BIPV, because the performance analyzer for simple solar panels may differ from which will be useful for BIPV. So that kind of considerations should be taken when you design a performance analyzer or a system for BIPV. So CSIO is doing that. CSIO also has created facilities under CRTDH. CRTDH is again a program by DSIR, Department of Scientific and Industrial Research, that is Cooperative Research and Technology Development Hub, which will test a 30 kVA solar inverter with a regenerative grid simulator, anti-islanding testing device, the way you connect and disconnect from the grid when power failure happens, loading rheostat, programmable DC power supply meter, grid connected inverter, signal oscilloscope, and DC-GT power adapter for multi-channel, and digital power meter. Some of these equipments are simple, but so far we have been importing these equipments, and now with the CSIR we have an in-house capability and expertise to design and develop these equipments. CIRI is a Central Electronics Engineering Research Institute, a lab again specializing in electronics. So as the name indicates, again, they are working on the electronics of solar PV panels and the accessories. CIRI has developed a solar PV-based EV charger, electric vehicle charger for 2- and 3-wheeler application. Presently, the work is going on to develop charger systems which can work with the grid or solar input. The setup can be installed in hospitals, office space, shopping malls. Basically, it can be installed in buildings. It can be part of a BIPV. And they have a solar canopy or solar trees like this, which can be used as the input for the battery charger. And all the necessary electronics have been developed by CSIR CIRI. This hardware is developed. Solar panel 160 to 231 volt panel can be used with output of 105, 135 volt. Efficiency is 97%, and the maximum power point tracker, constant current, constant voltage mode. All these things can be done with the system that is developed at CSIR series. Also, CSIR series has in the Jaipur center, there is an NABL accredited solar grid tied inverter test facility. So this is a national accreditation board for testing and calibration laboratories, which is NABL. They have given accreditation to the solar grid tied inverter facility developed by CSIR series at the Jaipur center. Okay. And you can see these certification numbers for MPPT efficiency, inverter efficiency, photovoltaic systems, and islanding prevention measures. This will become very useful once we have a specialized Bipv testing and validation facility, which we are trying to develop. At that time, all these things will become very useful, and these are the specifications for the system that they develop. Now, as I mentioned in the beginning, a lot of activity happening in almost all these 14 labs working with the energy theme, E2D theme, in materials, because it is the basic building block of any of these building integrated activity. So in dye-sensitized solar cell, which can actually lead to BIPV, we have activity on photoanodes, new dyes, electrolytes, device structures, and indoor photovoltaics, which is again a unique feature. We can proudly say that CSIR catalyzed the activity of indoor photovoltaics in India, particularly at NIST. The NIST, NCL, CLRI, ICT are the labs currently working on DSSA. There may be a few other partners also. So I couldn't put all the names here, but what I would like to say, these are representative examples and not a limiting case. So perovskite solar cell, again, novel materials, device architectures. In organic photovoltaics, non-fullerene acceptors, donor materials, donor acceptor porous organic frameworks, CLRI, AMPRI, IACT, these CSIR labs are working on developing these materials. CSIO has an activity on flexible graphene films, which can actually go a long way when we actually have building integrated large area fabrication. The transparent electronics, which was discussed in the morning also at length, that whether we need to go with ITO or silver nanowire films or any other technology. So here they have a solution with the graphene films, which is also now coming up. And in silicon photovoltaics, as we know that we do not have a serious activity of manufacturing of panels, but at the same time, we can contribute by surface passivation techniques, black silicon concept, silicon panel recycling, which is going to be a very, very important area, because once the lifetime of silicon panels are over, what do we do with all those panels? So end of life, silicon panel is going to be a serious question, and the CSIR has realized the importance of this area, and we are also having programs to address what we can do with silicon panel recycling, which is taken by NPL and AMPRI. And I would also mention that the silicon metrology is a very important activity. National Physical Laboratory, CSIR lab, is the monitoring lab of the nation for the standards. So it is their mandate and their duty to develop the standards for solar panels, which they are currently doing. And I hope with the time there will be separate standards for BIPV as well from NBL. And AMPRI is also working on surface passivation techniques and some modifications for silicon solar cells. So that is, in a nutshell, the activity of CSIR labs tied to the concept of building integrated photovoltaics. And we can say that in the Sustainable Development Goals of UN, if you look at it, with this work, we are actually tied to affordable land and clean energy, affordable and clean energy, decent work and economic growth, industry innovation and infrastructure, quality education, sustainable cities and communities, partnerships for the goals, and the climate action, which is again a very important topic. I'm not going into the details, but we have activity, we have a serious presence in these sectors where we try to actually address some of the problems which are haunting the humankind. So with that, I think I was able to give a glimpse of the activities which are happening in various CSIR labs on building integrated photovoltaic related activities. Thank you all.
Thank you, Dr. Unni, for giving a flavor of R&D activities at CSIR, and also you have touched upon our capabilities on not only on the R&D front, our technology capabilities are also showcased, and along with the testing and characterization capabilities is been touched. Thank you very much for this brief presentation of our CSR activity. Now, with this, I welcome Mr. Paolo Corti, researcher for BIPV Innovative Building Envelope Team at ISAC Subsea, for the invited talk on BIPV case studies in Switzerland. Mr. Paolo is also a co-founder and CMO of iWin Innovative Windows. With this short introduction, I welcome Mr. Paolo for his talk. Over to you, Paolo.
Thank you very much, others.
Thank you.
Okay, so hopefully the presentation is visible now.
Yes, it is visible.
Okay, so good afternoon, everyone. My name is Paolo Corti, and I am researcher for the Advanced Building Scheme team at Subsea ISAC, and co-founder of the clean tech BIPV startup iWin Innovative Windows. So today I would like to introduce the case study of an energy producing facade in a pilot building in Switzerland. But before jumping into the core of the presentation, I would like to start sharing with you the definition of BIPV provided by the International Energy Agency a few years ago, which highlights the idea of multifunctionality of BIPV. So a BIPV module is defined as a photovoltaic electricity generation unit, photovoltaic module, and the construction product together designed to be a component of the building. From this definition, hopefully or probably is easier to understand which is the potential for BIPV solutions, especially in terms of aesthetical integration, cost effectiveness, and technological performance or energy on the social aspect. And in this slide are presented three BIPV case studies, best practice that to me are representative of this idea. Top left is a residential building realized in Switzerland, in which the colored photovoltaic BIPV modules are installed in a rain screen facade, also on the discontinuous roof. Bottom left is presented a semi-transparent photovoltaic system integrated as a skylight on the rooftop of this commercial building, while the picture on the right side shows a multifunctional photovoltaic shading system integrated in the vertical facade, in the facade of this public building realized in Germany. This map represents the most iconic BIPV solutions realized in Switzerland in the last years. And it's just to introduce the idea, or maybe better, the fact that today in Switzerland, but also in Europe, the BIPV is well known, and partially is also accepted by the stakeholders of the construction value chain. But to achieve the status of mass market in the next years, in the future, we need to make a further effort, especially by the industry, research and university, public authorities and policymakers in terms of product or material development in order to offer a fully customized BIPV product, but also in terms of pilot installation, demonstration of the technology, dissemination, investment, standardization, and, for example, awareness. And here we come to the BIPV pilot installation realized in Lugano, that is a city where we are based in the south of Switzerland. Probably you cannot see it, but I promise that all the facades are fully covered with a BIPV modules. So in all of the facade, east, west, south, and north, all of these facades are fully covered with colored BIPV modules. The case study is a multifunctional building built in 2021, so it's a recent building, and the capacity only of the facade is 173 kilowatt peaks. Isaac Subsea was involved in this project, basically to provide or to promote R&D activities, and also for the validation and the demonstration of the technology. In addition, Subsea Isaac supported the stakeholders of the BIPV construction value chain within this complex BIPV process. Especially in the decision-making phase, in the early design stage, in the technical stage, and in the monitoring stage. Here I would like to present firstly the decision-making stage, that probably is one of the most important stage of the BIPV process, in which the stakeholders interact each other in order to find the strategies for the entire BIPV process. In this stage, Subsea support mainly the architects and the building owners in order to define the architectural features of the BIPV facade in terms of aesthetics, material, and technology. From the picture on the top right side, you can see the aspect of the photovoltaic modules used and installed in this multifunctional building. It is a color gray glass BIPV module installed as a rain screen facade. The second stage in which we were involved is the early design stage. We support some stakeholders to assess the solar potential and the cost of the photovoltaic facade. In particular, we define the layout of the BIPV facade by using different and specific BIPV tools, such as beam solar, in order to calculate the solar radiation on the facade, but also the shading or the self-shading from the building or from the urban surrounding. Regarding the cost aspects, we define the real cost of investment by using the cost breakdown and the extra cost method. You can find more detail than in the status report. And also we promote and we produce a sensitivity analysis, which I would like to highlight some the points that in this economical analysis, we saw that small variation of specific parameters, including energy yield, extra cost of subsidy, for example, could bring to a high competitiveness in terms of revenues of the BIPV solar system during the entire lifespan of these solutions. So the 30-year analysis in this case. Within the technical phase, we supported the BIPV manufacturer in testing and in the certification according to the IEC standards of the BIPV product. In addition, we also collaborate with the BIPV installers in the design of the electrical system. From this point, I would like to highlight that our results, our main results regarding the color BIPV module, so that we measure a 25% of power output reduction, measuring the standard test condition, due to the color applied on the glass of this BIPV module. This was calculated against a standard non-colored photovoltaic module. In this stage, I mean, we are working now at this stage, at the monitoring stage. We monitor the photovoltaic production and the energy demand of the building. And in order to assess a comparison between the simulated data calculated with a specific software in the previous stage, we like to compare the simulated data versus a real monitoring data in terms of production, but also cost. In addition, since we have to validate and demonstrate the technology, we are measuring also some technical aspect of the BIPV module installed on the facade. So once again, we were involved in this complex BIPV process, and again, we realized how complex is the entire process in order to realize a BIPV, to make a BIPV installations. However, we discover also, and this is a suggestion that I would like to show you, we're focusing on the decision-making process from the beginning, permits to anticipate all of those strategic decisions that would be important to reduce the risk, the problems during the BIPV construction stage. In addition, the other side, the interdisciplinarity, so the interaction with and between all the stakeholders of the BIPV value chain, is a key takeaway for a successful BIPV project. If you are interested to know more about this case study, please scan this QR code. You will find more information on the website, solararchitecture.ch. And thank you very much for your attention.
Thank you, Mr. Paolo, for that brief and very informative presentation. With this, I welcome Dr. Suraj Soman. He is leading a third-generation photovoltaics activity at CSR and IST. Over to you, Dr. Suraj, for a presentation on the possibility of DSSC for BIPV applications. Suraj. Suraj, please.
Am I audible now?
Yeah, you are audible.
Okay, the slides are also visible, right?
Yeah, very clear.
Yeah, okay, fine. Yeah. So, good afternoon, one and all. So, myself, Suraj, I work as a scientist at CSIR NIAST. So, today I will be literally speaking on the third generation photovoltaic technology with a focus on dye-sensitized solar cell, which has proven capabilities to be used as building integrated photovoltaic applications. So the title of my talk I had kept as indigenous colored and semi-transparent BIPV facades using dye-solar modules connecting India towards the Atmanirbharta in solar technologies for the future. So I'll be touching up the developments that we have done pretty much over the last 5 to 6 years.
Suraj, your voice is not coming.
Is it coming now?
Yeah.
Oh, okay, fine. So, as Dr. Ashish Lele mentioned in the introduction talk today, that the decentralized energy generation is something that we all need to focus a lot on. And the major target is actually to generate the electricity from the renewable resources, of which the photovoltaics, and particularly the first generation, which occupies more than 95% of the market, has a major thrust over there. But one thing, particularly for the developing countries and the other nations that need to be looked up into, is actually when it comes to gigawatt kind of installations, and when there is an unprecedented expansion in this solar photovoltaic expansion that is happening around the globe. This can lead to huge ecological and other human issues related to the diversity, livelihood, cultures, and these kind of problems, particularly in places where there is no barren land. So that actually looks us or like keep the vision more focused into the decentralized energy generation, where we need to target on building rooftop integrated and applied technologies for the future generations. So that is actually the relevance by which like more focus need to be given to the building integrated photovoltaic sector. And over the years, when we looked into the BIPV sector, we can see that majority of the market was actually occupied by the roofing and the walling. And it is projected that in the upcoming years, the facade is also something that more or less going to take the same kind of a market like that of the roofing sector. And when we look into the facades, it's particularly on the glass area, and there are a few parameters like the aesthetics, the transparency, the colors, and these kind of things need to be considered. And that actually involves the area of research that we are presently focused on, which is the third generation photovoltaic technology called dye-sensitized solar cells. In simple words, we can say that it's artificial photosynthesis, mimicking the same process that happens in a green leaf into a device. So it has a dye molecule, and you can change the color of the system by changing this dye molecule, changing the absorption spectra. And that is actually incorporated inside a device with two conductive glasses and a semiconductor, to which this dye is absorbed and an electrolyte is there. So here you have a multiple advantages there. One is the semi-transparency that you are gaining there. You can have any kind of colors by changing the dye system. Most important part is actually it works in all kind of light condition. It doesn't need to be the sunlight itself. It works well in artificial and the diffused lights, so it can have a bifacial kind of an application. Low cost processing, and the materials involved are like much cheaper, and less energy consuming process are involved in the manufacturing. And you have the possibility to move into indigenous manufacturing. You can get it into different shapes and sizes as per the requirement. And the over and above all this, the most important factor is these devices can be completely recycled and reused, leading to circular economy. So when we look into the history of this particular technology, even though this was discovered way back in 1991, and particularly like it also happened in Switzerland in EPFL in Lausanne by Professor Michael Gretzel's group. And over the first almost 2 to 3 decades, the more target was into the basic science development. It's not a mature technology like silicon or thin films, but in the last 2 to 3 years time, there were like large installation, particularly one in EPFL. A 2 kilowatt installation is there in Austria, Science Tower, which is a 25 kilowatt installation, and in China there is a 500 kilowatt installation of this Bipv modules using this dye-sensitized solar cell, really opening the eyes to the world, like what can be done with this particular technology, and still more efforts need to be placed in a way that it can overcome the value of death from and move towards the science to the technology part. So at CSIR NIIST, like we are working at the interface of in a truly interdisciplinary way, working at the interface between chemistry, material science, device physics, and engineering. And we are targeted into the end user applications, and accordingly the custom modifications are being done on the molecules and material side. And we target on applications on building integrated and transportation integrated photovoltaics, portable electronics, and a major target on the indoor light harvesting or indoor photovoltaics. And over and above all this on the supply chain development, which is very critical. So this activity has been taken up from more than a decade in this particular laboratory, and also in CSIR through various national funding options like TAPSON program and all. And we have gained the capability and understanding and had the portfolio of knowledge base in the science part and the material part in this particular device systems. And with that, we moved into the technology translation, creating an effective value chain from lab to market. And that involves the momentum starting from the fundamental R&D to the applied R&D, then to the fabrication and manufacturing. So one of the critical aspects that we addressed at that point was the indigenous equipment development, because if any technology need to be sustainable, you need to have the equipments which are used for the manufacturing to be produced indigenous, so that the cost of production can be reduced in a bigger way. In this regard, with the support from the DST, we have realized the true indigenization, developing a series of semi-automatic fabrication equipments for the disolar module fabrication, partnering with our industry Elixir Technologies in Bengaluru, and where we realized a cost reduction of 60 to 70%. So this was a major initiative in the country. And we were able to make small area cells to mass master plates and the modules up to a size of like 30 centimeter by 30 centimeter. And this was aligning with Government of India's initiative on Make in India, Atmanirbhar Bharat and Make for the World. And this was actually showcased in various forums and was also selected as one of the technologies under the CSIR 80-year success stories. So moving ahead, so this is actually the module process flow, like Dr. Unni has just touched upon on the things. So we start with the screen printing, and then there is a 5-head robotic system which is actually used for a range of various applications on the silver grid lines, and also the pick and place, the electrolyte filling, and various stages of the development, and finally getting to the prototypes and the final product line. So another major activity that we have taken up at that particular point was that once we have the equipments, once we have the process, the most critical bottleneck was the supply chain. Until or unless you don't have a supply chain indigenously in the country, no industries will come up and take it up into the commercialization part. So here, with support from CSIR, one of the most critical supply chain was the conductive substrate, like normally the FTO, which is used in this particular devices. So that occupies around like 70 to 80% cost. So in the last 2 years time, we have indigenously developed some systems by which we can actually make these kind of conductive coated oxide substrates which is benchmarked with the performances like incomparable to what is already existing out there. So along with that, we do have the technology and the portfolio now for a series of other materials and molecules which are used in this particular set of devices. Another major activity that we have taken up after that, like when we speak about building integrated or building applied photovoltaic applications, it's not just the things which are outside. So we need to actually think from inside the building also, because we all know, like in the COVID times, most of us like we are sitting inside the closed spaces and a lot of energy is around us, like particularly in the form of the light from the artificial light sources. So how we can actually harness this energy in the most efficient and effective manner and use it for various applications, particularly like for the self-powered IoTs and those kind of smart applications which are there in this fourth industrial revolution era, which is quite common these days. So there we focused on this indoor photovoltaics, which actually has a potential of reaching up to 57% efficiency depending upon the band gap of the material that is being used. And out of the various technologies, solar technologies available, dye-sensitized solar cells occupy a very prominent position with efficiencies reaching up to like 35% over the past 2 to 3 years time. And it offers the flexibility of integration to various electronic gadgets. And thereby, at the end of the day, what we target is to have a battery-free world and to use the energy, the recycle the light which is around us in various forms. So CSIR NIST presently holds almost 5 world records on this indoor photovoltaics, and we are actually the pioneers globally in this area where under the CFL light we have an efficiencies of reaching up to 35%, under LED light just about 30%. Under the ambient light conditions of around 6,000 lux, we have reached up to 40%, and particularly like from the voltage point, because when it comes to energy harvesting circuits being used for this IoT applications and all, higher voltage is actually a prerequisite. So there, with our design principles and use of new materials, we have even reached up to 1.3 volt from a single junction device. So here, like you can reduce the footprint of your devices over there. So here I will just show you a quick video where you can see a device which is less than 1 centimeter square was enough to power a temperature sensor down here. So here you can see this is a temperature sensor and the intensity is less than 200 lux, and this less than 1 centimeter square device is able to power that particular device. So this is actually where we are targeting, and the performance of our indoor photovoltaic light harvesters have been actually benchmarked with the international standards. So like there are 2 companies that had released the white papers on this indoor PV sector. One is Ampian Photonics from USA and another one is 3G Solar from Israel. And based on their data, and when we are comparing it, we can see that with an active area which is 1/4 of what is being reported by these companies, like we were able to generate at least like 20 to 30% more power under the standard 1000 lux condition, and the same is actually being reflected under the more realistic light intensities of 200 lux or less than that, also maintaining the same power density out there. So in a nutshell, like what we are targeting is to take up our expertise in this particular area from the science that we have done over the past decade, and then the translational research and the experience that we have gained over the years in the technology development, and see the potential in various sectors like building, where like not only the building integrated system, but the systems like the furnitures or those kind of artifacts which are inside the building can actually evolve to generate the power in the indoor photovoltaics area. In the transportation sector, like the noise barriers, or like in trams, trains and all, like where both inside and outside light can be used, and some innovative applications like the urban rooftop farms and all, like where these colors and aesthetics plays a very key role for the future development of this particular technology. So to conclude, we emphasize the importance and dire need for harvesting all forms of the light, artificial, ambient, diffused, catered to the resurgence of this particular technology for BIPV and indoor photovoltaic applications in the country. Indigenous manufacturing and most importantly recycling and reuse is possible with this, and that contributes towards the circular economy, and the development of an end-to-end decentralized ecosystem and supply chain development is being provided to take up by the industries, those who are interested. And this finally leads to the goal of the government, which is the import substitution and Atmanirbharta in the solar technologies for the future. Thank you.
Thank you, Dr. Suraj, for a very interesting talk on third generation photovoltaics and its possibility for indoor light harvesting. With this, I will move on to our next speaker, architect Anand Sabu. He's a founder of Sahayog Design Pathway Private Limited and director of Megajoules. He is specialized in strategic design management, and his basic portfolio comprises of wide range of building design, ranging from working on retail sectors, corporate, and research for multinationals, and teaching design thinking for various professional and educational institutes. With this short introduction, I welcome architect Anand Sabu for his talk. Over to you, Anand.
Thanks for the introduction, Dr. Adesh, and inviting me here. And thanks CSIR and NISST for doing such a wonderful job, which is there. So I'll start our company, which focuses on energy aspects and design in energy aspects, is called Megajoules, where we energize the buildings, and with what we call that we energize your building, and which was so I would start with saying that alternate energy is the future whose time is past, and renewable energy is the future whose time has come. So every second our sun produces enough energy to sustain Earth's need for next 5 lakh years. So that's the thought I would like to start with. So Megajoules, it's an energy division. We are completely a knowledge company who's under the umbrella of Sahayog Design Private Limited. And it started in 2010, where our thought as an architect and focusing more on sustainability. The vertical in Megajoules, we were looking at energy responsive habitat designs. So the habitats are basically the buildings or the build structure which is coming, and we and support architects and urban planners to look at daylight analysis, thermal analysis, and other parts of passive design strategies. And in that part, one of the aspect was, can we have building envelope energy systems? And that was a decade ago, a thought which came across that we need to have decentralized systems. And at that point of time, solar rooftops and other system was also coming up into Indian and subcontinent. And in 2013, we were looking at envelope systems, which could also look at other than top, the other envelope system, the 4 directions which are there. And we were incubated for that part to National Design Business Incubator in Ahmedabad, which is the startup wing of National Institute of Design, where I have done my master's. And there we looked at this envelope systems which are there. And then we have recorded, and then we installed our first system into the building where we were incubated. it was a small of 1 kilowatt system which was installed, and we recorded the data, and it was installed on the east side of the building. We recorded the data, and then we were started looking at various projects, and the data was really the data which we got at the real time after simulation was real data was much more better than the simulated data which we have predicted. And there in 2014 we pitched for the project the data which we have looked at for a year, how the production is. And then this is the latest image of 2022 of Atal Urja Bhavan, which is MNRE's corporate, the main building which is coming up on Lodi Road at New Delhi. We were fortunate enough to get to look at this design with courtesy architect who were Edifice Architects, where we assisted them to look at a complete design process where how can they integrate solar. So this is the final image, but then the journey started in 2014, where it was a blank spot which is there, where the design was given. It looked at on the left and bottom, it looked something which they have predicted that how would they visualize it. So we started its simulation with all the 4 surfaces, looked at giving them information how project on the western side, eastern side, and southern side, how it would perform, looking at the efficiency, and all of that at that point of time we have simulated using the tool called Beam Solar, which was talked about earlier. We used that Beam tool which was available and was shared to us. So we worked on that to generate simulated information which is there. And then there was a final understanding that on the southern side, with that sort of size, we would be developing 200 kilowatts of system on the southern side, which was there. And all the data and the sizes were given, and then the system was tendered to the company. In the complete process, we had done all the simulations for the southern side, which was there. And when you look at the simulation, of course, at that so the initial simulation was done into BIM Solar, which was there. The later at the stage, because people were not equipped with Beam Solar, and that's a challenge. That's a Bipv simulation tool, but here we have to simulate that to authenticate, because PV-Syst was the system which they were looking at. That's why the challenge where we have to, because PV-Syst is not not at that point of time in 2016, when, if you can look at, was too equipped. We had to do a lot of because it's a building, a complex building which has to be placed, and the southern facade has to be simulated. We have to simulate it, and if you can look at the curve, it's completely reversed than the rooftop curve, because in the June, July, the summer season, because of the non-inclination system of the panels, were getting a reverse sort of curve, and that's fine, which we have predicted earlier, and that's how the journey and the BIPV behavior in the Indian subcontinent looks like. And then the detailed drawings and details were also shared in the complete process, and the complete detail of structure and everything, because the wind load has to be taken care into that aspect. And then finally, what sort of solar panels we have used, monocrystalline systems for this. So and various others performance products were reviewed. This was in 2019. If you can see, check that it was Panasonic, which was their sun power panels were also reviewed. So all the other panels were reviewed to look at the performance because we have initially, the project had started in 2014 and 15, and now it was 2019, so as a consultant, we have to review the latest technologies which is to become. And when we look at a large building process, the tender procedure also, it was looked at what will be the latest technology at that point of time would be looked at. I would say this is not the latest technology, but this was something which was cost effective. and cost efficient into the investment and the return which was going on. And that's why the monocrystalline system was kept across during this complete during the time of the installation process. And the complete sort of detailed understanding which was given to them about the efficiency, module efficiency, and number of panels which would be coming. And then the final procurement had started, because we have to relook at the complete latest technology and evaluate it as per the tender which was submitted earlier and submitted. And so the cost effectiveness has to be also reviewed. And the similar process of simulation was done again during the execution time. So we are under the limit of limit where this much solar has to be generated, because this is one of the largest net zero building, because here the thought that this would be the benchmark building where net zero production has to be taken care. And yeah, this is the final output which I showed you. It's 1176 kilowatt of production which happens. The roof looks at 945, and the wall which you see in your front is 231 kilowatt of production. I'll just look at other project which is much more experimental and a fun project which we have done, and that would be the final part. But here the experimentation, here the cost and infrastructure, everything was available. But when we look at the experimental part, I will come across a small project which we have done in Daman, which is the eastern part of India, a small island sort of system which is there. So it is a small sort of installation which was an experimental project where we were looking at a small solar tree system where the sun comes, and the concept that we get light and that sort of thoughts which were evolved. And then the complete system was looked at, what sort of harness of the product which will be there, which will be reducing the part of the battery could be at the location of the where the production is happening. The complete production shadowing impact was studied, and then the complete electrical systems and how it would look like, the solar, the shadowing, and of course it was again the simulated part which was done. And then after installation we had reviewed the production for a year. This production was also reviewed, third-party audit was also done by Jeremy, which is located in Gandhinagar in Gujarat. And then we have looked at all the production hours, how it will how the production happens, and throughout the day, which is there. Of course, we had the monitoring system which looks at it, and this is the final product which you look at. It's the circular. Of course, it's again a mono crystalline system which was done, but how we have put forward with looking at other aspects which is there, which comes across. We have used stainless steel and insulated systems, so the panel also has the sturdiness which comes across, which is there. And this is the 2 kilowatt systems. So when I look at, as an architect, what sort of work we have done and what sort of things have come across as a challenges are, of course, in the earlier presentation, the aesthetics which comes across, which are there, how it is integrated into the design process, and the journey of the complete design the design process to the execution and evolution of technology. It's 8 years from 2014 of conceptualizing it, in 2012 when it is coming across here. So that's where we have to also look at the concept and also make the client and the team get acquainted with the latest technologies which are coming. So we don't do something in 2022 which is of 2014. So it was also relooked as a re-evaluating the latest technology when the time of execution came across. And that's the challenge which I look at, because the time of journey of the project also is really important when we look at, and that has to be incorporated when you look at a large scale installation. And when we look at BIPV systems, there are all the other projects. So that's where we also educate our client that this is a journey. When we look at a 4 years of execution, when we look at 1 megawatt or 500 kilowatt or 200 kilowatt of production happening through the wall surfaces, we need to look at the journey of look at what sort of changes can come into industry, and we have to look at that and bring the best which is possible. Yeah, thank you everyone, and thanks CSIR.
Thank you, Anand, for detailing your experience with MNRE, especially on Adal Akshay Urja Bhavan project, and the importance of project detailing, basically involving the APV from the design stage itself and the challenges that you have faced. Thank you for sharing that experience. With this, we will move on to our very important section, that is Indian BIPV industry section. We have eminent speakers in this section. First, we will go with Mr. Pashupati Gopalan, co-chairman and CEO of Sun Edison and co-founder and CEO of Ilasini Housing, for his talk as an expert from Indian BIPV industrial sphere. Pashupati Gopalan is a thought leader and a visionary in energy and sustainability. Pashupati was also named as a solar power person of the year 2015 in India. With this short introduction, I welcome Mr. Pashupati to deliver his talk. Over to you.
Thank you, Dr. Ashok. So basically, I think just a few words about Sun Edison, and we'll tell you what we have done in BIPV. I think as a company, our heritage is more than 65 years old. We were the first company in the world to commercialize silicon, which is the foundation for the entire solar industry, in 1957. We've been doing directly solar business for more than 20 years. We've been present in India since 2009. We did many pioneering projects in India, like the Narmada Canal project, which the Prime Minister fondly shows off, and also many utility scale first projects, first rooftops in the country. Today I'm here to talk about, we are introducing a new line of BIPV products. The reason for that is, solar the general solar rooftop, they don't have visual appeal. Typically, the color may be different, and the system does not look as good, because some people go to a great extent working with architects to build beautiful bungalows and villas, and the solar system with its color and the way it's designed may not fit in, and that might come in the way of adoption. So our effort was to develop a solar roofing system, which essentially can also, from an economic perspective, replace the roof. So it gives the dual benefit of both the roof as well as generating renewable energy, green power. So this is called ARCA collection. If you go to the next slide, Abhishek. So basically, ARCA collection is based out of solar tiles, which are each about 77 watt peak. These are designed for all weather conditions. They can withstand, the design of the system can withstand very high wind loads of 170 kilometers per hour. Completely integrated power electronics, AC/DB, and everything. So clearly, because of all the integration, there has been a lot of thermal challenge. These are BIS approved and IEC approved as well. And as I mentioned earlier, these can withstand category 3 hurricane and come with a 25-year performance warranty with 24/7 monitoring. And we designed these power roof even as gazebo. I'll talk about it, but basically you can take a closer, this is a close-up photograph of a real installation we have done in Bangalore. All of you are welcome to come and visit it. So basically, these are systems which can essentially replace the regular roof and be completely building integrated and essentially completely revolutionized. So it's the biggest thing about this is, since the theme of the discussion is Atmanirbharta and BIPV adoption in India, this is 100% developed designed, developed, and manufactured in India. These solar tiles, which use mono-PERC cells, we build these tiles, which are glass-on-glass tiles, in India. So that's all. I think all I'll say is we can use them also as gazebo, which can be used to create lounge space and expand your living space in a garden or a terrace very comfortably. So without compromising on the color, we do have 3 different colors, but essentially without compromising on the color and the visual appeal, we can get this beautiful aesthetic solution, which is completely developed in India and manufactured in India, to give you both green energy as well as a beautiful sort of integrated to the built environment. So that's all. I just wanted to share these few words, and we are grateful to CSIR NIST, as well as the Institute of Applied Sustainability to the Built Environment from Switzerland. Thank you very much. We look forward to continue to work with you. But we believe that this is a pioneering solution that's been born in India, which is essentially, will hopefully change the adoption of BIPV in India significantly. Thank you very much.
Thank you, Mr. Parshu, for maintaining the time. And it is very insightful to go through the Akka collection, specifically for the aesthetics gazebo that you have already there in Bangalore Villa project. And with this, we will move on to our next speaker, Mr. Jindo Joseph. He's Assistant General Manager of Topson Energy Limited. Jindo has experience of more than 10 years in the solar segment and handled multiple BIPV projects, and also he is involved in product development of photovoltaics, glass units for basically focusing on glazing solar rooftop tiles, and also focus on the concepts of daylighting. With this short introduction, I welcome Mr. Jindo Joseph for his talk. Jindo, over to you.
Hi, thank you, Mr. Thank you, Dr. Ashok. I believe my slide is visible and my voice is audible.
Yeah, both.
Thank you, and thanks for this opportunity. So here, myself, Jindo Joseph, I'm representing Topson Energy Limited. So Topson, hope you might be heard about us. We are a manufacturer of solar PV module. 2007, we have established ourselves with a 10 megawatt of manufacturing plant, and today we stand at 250 megawatt. So where we offer both monocrystalline and polycrystalline technologies with all the possible technologies that is available in the market as on date, like BIPV also. We have a couple of different products which we were working on. So before going to my slide, I just would like to tell you the concept which thought of thinking our management towards the green building or the BIPV concept is today. The glass envelope building become the cultural icon. But we cannot say that all the glass are considered today as a green. Natural daylight is one of the leading drive for today's architectural design. Heavy glassed building material consume more energy than less glassed material, less glassed building. So this was the thought made our management to think of concentrating or thinking something different towards a real energy efficient world. So that is how 2015 onwards we were thinking of doing something different to the industry, and we have developed our own R&D wing, started doing development on this BIPV concept, especially glass to glass concept, which can give much boost to the architectural designs aspect now, the building skins now. So I'm just moving to my next slide.
Thank you, Jindo. Thank you for highlighting the importance of glass module and the importance of daylighting for building structures. So with this, we are moving on to the panel discussion. This will be the final section of the event. For this section, I welcome So myself, Dr. Adarsh, will be the moderating the panel discussion, and a very warm welcome to all expert members to the panel. And today's panel discussion theme is Indian BIPV sector challenges, opportunities, and way forward. I will start this section with Dr. Pelluji Bonoma. He is the head of Advanced Building Skin team, Swiss BIPV Competency Center, ISAC SUBSI. So coming to Dr. Pelluji, from your experience in the BIPV sector, which perspective for research are the key factors in pulling BIPV market?
Thank you, Adarsh. Thanks for providing the question. I will try very briefly because I mean the question has a lot of sub questions possibly, and maybe first of all I will briefly focus on the market topic that you included in the question. Since BIPV market itself, we all know that it's a kind of hybrid between two sectors, but honestly I would say that in my opinion main BIPV market is the construction market. I think Mr. Sabu and also the industrial partners clearly highlighted this point. So the final use of BIPV technology is the building skin. So the main drivers for the technology are the different aspects of the construction value chain. I mean this is pretty clear, but it's a change of perspective. BIPV technology, I mean, if we are in the mind of an architect, I think BIPV technology should clearly satisfy aesthetics and also the emotional aspect of a project. At the same time, I mean, if we are building engineers, technology should satisfy performance and quality. And the same, if we are building owner, we want that technology is cost effective and is efficient, has a good lifetime, and so on. So I think this is quite obvious, but if we relate all these aspects to the integration of a solar system, we easily can understand that we need to consider BIPV as a real construction product and as a part of the building process. So just briefly to fix a point, I would like also to know if also the rest of the participants agree on this point, but I would focus on the topic that we need to transfer technology and processes on the building and construction market as a first point. Then I come closer again briefly to the key part of the question. So what's the perspective of research? And I can also here, I can highlight first of all that fundamental and applied research are quite complementary and synergic in my opinion. I think today we again demonstrated this, and I mean, in my perspective of a more applied research, I would just say that research needs to consider very clearly which are the market needs. So, in my opinion, research questions should always start from market KPIs. So from real needs of stakeholders and of the different stakeholders involved in the process. I just briefly conclude, I don't want to bother you with a lot of aspects, but just providing an example of applied research that we developed in the framework of this BIPV Boost European project. I briefly mentioned before that we focused on the topic of standardization in terms of product testing and quality assessment. I think this is a clear example of a research field which is closely related to the market implementation of the technology. So the basic research questions that we are addressing is how do I have to qualify a multifunctional BIPV product, which is the state of art in construction and in the electrotechnical standardization world, what I can basically use of existing rules of standardization, but at the same time, which are the missing gaps. We made evidence of some missing gaps for some technical requirements where standardization and testing rules need to be a little bit updated and fine-tuned for active building components. So I could mention a lot of activities on that. So we developed new testing procedures in this framework, but I don't want to go in details, just to highlight that since we need to create a high quality market of BIPV, so we need to establish confident products for the building owners and for the clients. I think this is in the interest of all the players to have a clear qualification and certification framework of these products. So this is basically one of the key points in Europe. I would be curious and glad to understand if this is also a challenge in the Indian framework, and which are your reflections about that, if this can be, for example, a collaboration point among all the stakeholders.
Yeah, thank you, Kolleji, for that wonderful insight on that, basically focusing on the standardization aspect. So now we have with us Dr. Jay Prakash Singh, Technical Director of National Institute of Solar Energy. This is coming under Ministry of New and Renewable Energy. And it is a pleasure having you on the panel, Dr. Jay Prakash. Could you comment on the requirement for exclusive testing certification, testbed facility and capacity building program for BIPV sector in the country, and also briefly touch on the current barriers for the same?
Okay, thank you, Dr. Adarsh. Just to start with what are the testing and standardization requirement. Actually, as you know, that BIPV is like a relatively new technology or new product, and also because this is not a independent product kind of other PV module. So we have to go hand in hand with the building industry, and in country and different countries you have different building codes, buildings requirements. So this is also one big problem which put on these aspects. Then if we talk about like a standard testing, although there are some standard available for BIPV module testing as a part of like a IEC standard, and most of them are following with the those which are with the standard testing. For example, 61215 and 61730, which are like a type testing and type and qualification testing, and then safety testing. So these two aspects are as it is like taken from there. But here I would like to emphasize that for these modules, certain things should not be tested exactly in the same way as for that standard module. For example, if you talk about like loading condition because the loading conditions are different, and then building integrity, all these things are different in a building. And if we talk about like for example fire test is already there in India. It is mandatory to have a fire test for any module for qualification test. So this is good for those module, and same as this one is ignitability test. But other than this, because these modules are installed at certain angle, not just like a latitude angle where all other modules are installed. So most probably one good thing to test these module could be like a angle of incident performance, because this is a part of performance, not as safety, but still it affect your energy generation. So it need to be taken care of. And then one important aspect is hotspot testing. In standard modules, the hotspot testing is very well defined, but sometimes that is not, I mean, it cannot be directly translated to these BIPV modules, because they are quite often experience this hotspot and shading condition. So these things should be revisited, and more importantly, building codes and building like a material also need to be taken into the consideration. As far as infrastructure in the country, in India, involved, I would say that specifically we do not have any lab for BIPV specialized testing, but we all do these testing in our standard lab where we do our standard module testing. So whenever some module comes for this purpose, so we do test as per the standard IC 61215 and 61730. So I think there is a need to work with the building industry as well as that with the PV, so that we can combine the new requirement. And I think this has to be little bit country specific also, because of the building design involved in this one. So yeah, I think this is from my side on the testing. Then related to skill development, because we are also involved in skill development. So far, we do not have any specialized course for BIPV. For example, we are starting new courses as the need comes in the market, and we start looking into those aspect of developing like a skill, enough labor for putting these modules into the field. For example, currently we are also involved in this evaluating the standard, evaluating the a potential in the country for different technology, not only BIPV, it's whether it's a floating BIPV, agrivoltaic, all these things are like a new application of photovoltaic. So once this is very well proven, the industry will go in that way. We will definitely will have such courses in our portfolio as well. Yeah, thanks.
Thank you, Dr. Jay Prakash. As you mentioned, with multifunctionality for either in the case of BIPV or agrivoltaics, if it comes with a multifunctional offering, it is always it is very important to say, for us to setting up the standards and certification in the country. And you also appreciate that the requirement of testbed facilities for testing the new upcoming technologies and they get it to the market at the earliest. And now I move on to get insight on favorable policies from the State Energy Agency perspective. So we have with us Mr. Pramod Enni, representing an agency for new and renewable energy research and technology, ANERT. Mr. Pramod, over to you. Could you comment on policy initiatives, more specifically on rooftop PV, role of buildings for decentralized green energy supply? As we all know, now electric vehicle is coming up in a big way in the automobile segment. And also, could you comment on the potential of BIPV sector in the country as such?
Good afternoon, all. Am I audible?
Yeah, audible. You are audible.
Good afternoon, and thank you, others, for inviting me to this session. BIPV, unlike the rooftop solar PV, we require working in tandem with the builders also. And if you look at the targets fixed for solar PV, we can see that in the 100 gigawatt proposed by the end of 2022, 60 gigawatt was for the utility power plants and 40 gigawatt was for the rooftop systems. But when we see where we stand in achieving the targets, it's almost 97% of the target on utility scale power plants have been achieved. And in the rooftop sector, it is slightly lacking. So we have to concentrate surely on the rooftop section, and this is where the BIPV gains its importance. So maybe the rooftop system, it is not gaining momentum in the country, and if we go with BIPV, it may pick up the momentum, because there is it's an integral part of the building. But maybe on the policy front, we will have to involve the building designers and architects also. We should first create awareness among those people, and they should be the drivers of this technology. That is what I feel. So again, like any other technology, it should be the government who leads the way. So first, the government should be in a position to maybe support and have some buildings with Bipv so that the people get attracted to this technology, and it gives, maybe it becomes more popular. And again, this rooftop technology, along with battery operated vehicle. So that's a very good combination, and whoever has the rooftop power system, maybe they'll be supplying excess power to the grid. So it is not that lucrative when we see the monetary aspect of it. But if he has the battery operated vehicle also with him, then he can use more energy, and maybe all the energy from his rooftop will be utilized. So that's a very good combination. And if we can integrate that Bipv into this battery charging also, it would be a good thing to happen. And the policy should be modeled accordingly. Thank you.
Thank you. As we also appreciate that very recently our rooftop policies are being redefined, and now the user, I mean the building owners, have the flexibility for selecting any module manufacturer. I hope this will be a boost for Bipv implementation in the country. With this note, now we have with us Dr. Narayan Unni, CSR Energy Conversion Vertical Lead, Ministry of Science and Technology. Dr. Unni, Dr. Jayaprakash has mentioned about the requirement of standards, certification, and testbed facilities for Bipv innovation and product standardization in the country. So, as a CSR Energy Conversion Vertical Lead, could you comment on how effectively research organizations like CSIR, NICE, and in collaboration with Lime Ministry to realize this goal? For example, the requirement, as we discussed widely throughout this section, requirement of standards, certification, and testbed facilities. Thank you, Dr. Unni, over to you.
Yes, in fact, I was excited to hear what Dr. Jayaprakash from NICE mentioned about the need for establishing separate standards for Bipv, because I think he insisted that the standards that we generally use for our normal solar panels might not work for Bipv. There can be a separate set of standards depending on many factors. And this actually recalled an incident that me and Dr. Suraj Soman, we visited NICE probably, when was it, Suraj? Maybe 3 years ago, 4 years ago?
4 years back.
4 years ago, we visited NICE and saw the facilities there. And we found that this is very good facility for testing and validation of solar panels there. In fact, at that time, we were planning to submit a proposal for a CRTDH, Cooperative Technology Development Hub, for certification of solar panels. We came back, and I think Dr. Pramod is also here. We had discussion with ANART at that time, because ANART was doing pre-qualification of bidders for installing solar panels in Kerala at that time. So they were also looking for somebody who can actually do the pre-qualification. Surprisingly, we found that in Kerala, in general, people are going to Bangalore, Central Power Research Institute, to do the validation of the panels. So at that time, we were not thinking about Bipv, but let alone Bipv, we don't have any testing and validation facility in Kerala for any photovoltaic. That is what we found. Then we thought probably there is an opportunity to set up a facility, but due to many other reasons at that time, we couldn't push it. But now I see that CSIR, if you ask me, CSIR is well placed to take up this challenge and do it, because the National Physical Laboratory, NPL, is the National Metrology Lab also. So they are the custodian of national standards in this kind of areas. So even if you set up something with the CRTDH or any other facility, it has to have a kind of accreditation from NPL. And with that background, I think we should be able to do that. Second part of your question is that the policy regulations and all, yes, CSIR and CSIR higher authorities should in fact take it up and try to define new standards for BIPV, as Dr. Jayaprakash Singh said. But it's not only the prerogative of a CSIR. It is with the MNRE also and all the different stakeholders in this sector. But along with them, I am quite sure that the CSIR can do their bit, because we already have expertise in the lab level devices. To some extent, we have expertise in module fabrication, characterization, and we are aware of the kind of standards are set for solar panels. But if we define a separate set for building integrated photovoltaic, we will be happy to be part of that endeavor. Thank you.
Thank you, Dr. Unni. Indeed, it is a need of the hour to seriously think about setting up the standards and certification process jointly with the Line Ministry and NICE in coordination with the state agencies. So now we have to make this panel discussion more meaningful, and we have with us industry representation, Mr. Abhishek Padmanabhan from Standardization, Mr. Jindo Joseph, AGM of Topsun Energy Limited, and Mr. Ankit Modi and Mr. Viral Shah, founder and managing partner of Elis Turbine. So my question is to Mr. Ankit Modi from Elis Turbina. As a vibrant BIPV startup with many BIPV product offering, the question is how you find it easy for certification requirement for claiming the multifunctionality offering for your BIPV products.
Thank you, Dr. Ashok, for this wonderful opportunity. As you rightly said, that we are a green energy startup and trying to integrate all these products into not just into buildings, but also as a net zero individual product. So certification plays a major role. But unfortunately, since there is hardly any norms or standardization for BIPV, as Dr. Jay Prakash has rightly said, what we are doing right now is we are doing a national building code compliance product. So we make sure that all our basic product, all the base material which we use is all national building code compliance and compliance with the local regulatory. And then we integrate IEC certified solar panels with this product. So we make sure that we have dual certification from solar panel perspective also, as well as from the national building code compliance also. But as the need rightly says that we definitely need a standard BIPV norms, something which UK market have recently come, like MCS certification for a bespoke BIPV product, which is MCS 17, where it does all the testing from mechanical to electrical side from a solar module perspective, but it also gives us the flexibility to have a design flexibility, right? For example, instead of 72 cells module, we can have a 60 cells module in the same size, which allows the daylight to pass through it. So this sort of flexibility is required when we think about a BIPV-centric standardization, where all the standard load capacity, wind load testing, all the testing needs to be complied of, but also it should have an aesthetic value to it. Aesthetic flexibility must be there. So the common norms, common standardization, combination of all the national building code compliance, as well as the compliance with all the IEC code, that two combination is required to comply with the BIPV products in near future. So I look forward to have this standard things going forward, where we can have a single window compliance for the entire BIPV products going forward. Thank you, Doctor.
Thank you, Mr. Ankit, for marking a very important point here about the requirement of capturing the multifunctionality aspect of BIPV in the standard for developing standards and certification process. So I have an announcement. We have exhibition booth is going parallel with this panel discussion. Those who are listening online, I request all of you to visit the exhibition booth from industry and from CSIR side. Also, we have an exhibition CSIR and ISAC subsidy side. Also, we have an exhibition booth. So now moving on further, my next question is to Mr. Abhishek. As Standardization as an international player in the photovoltaic sector, and from this experience, how do you analyze the scope for Indian BIPV market?
I think the fact that we have released a product which is designed, manufactured in India, specifically for Indian consumers, is testament to the fact that we are seeing a lot of So am I audible?
Yeah, you are audible.
Yeah. So yeah, so it is testament to the fact that I think there is a lot of adoption of BIPV solutions happening. So in our own sale of solar in India, we saw that around 10 to 15% of the population who were interested in solar were dissuaded by the fact that there was some sort of aesthetic issue with it. So I mean, they didn't want to integrate it. So typically when we are taking say 100 leads, out of that around 10 to 15% of that would just say, look, this doesn't look good on my roof, I can't go with this. Some fraction of this, we think around 5 to 10 people will definitely go for BIPV solutions for every 100 people who are in India. A lot of early adopters. So in this case, we are looking mostly towards the villa community as early adopters. People who have independent houses, they actually are quite sensitized to sustainability and so on. But at the same time, they have spent a few crores on their villa. They've spent maybe 2-3 crores on their house. They don't want to ruin the effort they have taken to create a space which is according to their specifications. So I think BIPV offers this very unique opportunity to them in the terms that I am personally quite convinced that you will start to see a lot more BIPV coming up in India. As the ecosystem develops within India, I think the costs will also go down for consumers, and I think with the cost going down, it becomes more accessible to people outside India.
Thank you, Mr. Abhishek. Now, my next question is to Mr. Jinto Joseph from Topson Energy Limited. Topson being a major player in the BIPV segment, could you comment on the major supply chain limitations and you are facing for BIPV product development?
Thank you, Dr. Adarsh, for putting me the question. First of all, I believe I am audible. Maybe I was not able to complete my presentation. There were some network issue.
Yeah, you are audible, Jindo.
Okay, thank you. So that was a fine question. See, like as a major manufacturer of BIPV module, see the major problem we face from supply of solar glass. See, the BIPV segment, the requirement comes as a customized requirement. See, case to case, requirement to requirement, customer to customer, their motto, their requirement are something different. Some may want to go for different transmittancy level. Some would like to have different glass sizes. So what the major challenge we face from our glass supplier is to get the customized glass size on time delivery. This is what the major challenge we face it, or else all other material supply are in line with to comply with the delivery schedule of customers.
Okay, thank you, Mr. Jindo. Now we will move on to the colleagues from the Central Building Research Institute, Dr. Tabesh Alam and Dr. Vinod Chowdhury. Dr. Tabesh, as a thermal engineer expertise in this area, could you comment on the requirement of standards and also do we have any similar standards we can adopt from the building sector?
No, as such, the standard for the BIPV is not available in India, but there are several standards available for testing the solar thermal collector. So these standard for the flat plate collector, glass evacuated glass solar collector, concentrated solar thermal collector. So these are available in India, but as such, for the BIPV, there is no such standard is available in India.
Thank you, Dr. Tabesh. Now, to the question is to other colleague, Dr. Veena. Could you come on the importance of exergy analysis for the BIPV system?
Yeah, good afternoon to all. Yeah, everyone talks about energy analysis of the thermal system or the solar system, but we should also done some courses on the importance of exergy in the thermal system analysis, and we should utilize the exergy. To enhance the performance of the system so that we can get the better efficiency and that and minimize the losses with related to the system. So we should also talk about how exergy is important for any system which we are using for that energy consumption.
Okay, thanks, Dr. Veena. And more on to the third generation photovoltaics. Dr. Suraj, could you quickly comment on the global status of third generation BIPV, third generation photovoltaic sector, and more specifically on BIPV?
Yeah. Actually, when it comes to third generation photovoltaics, nevertheless, like compared to the conventional silicon and thin films, this is not a market leading technology. This is an upcoming system where more focus was on the basic research and development. And over the past few years, there was a technology translation where people are adopting this technology due to certain reasons. One thing is the ease of manufacturing, the lower cost of production that is involved. And particularly like when we look into the BIPV market, like who will be the main players who are involved, they are all procuring the silicon, either the monocrystalline or the polycrystalline silicon, and then working on with the architectures. But in the case of these kind of new generation technologies, your starting material is glass, and then like you are doing some coatings, either in the form of screen printing or blade coating, and different layers, and making it capable for this light harvesting application. So in a way, like the process is like much cheaper, scalable, and involves like materials which are also at a lower cost. And particularly with the recycling possibilities that are presently available, like there is no end life for these devices. So once it starts to degrade, like you can just take it back and you can refill some of the systems which are inside, and you will get the device back to normal. So that leaves some new innovative possibilities for it. And particularly when it comes to the conventional BIPV sector, you target for outside photovoltaic applications, like targeting the harvesting the sunlight. But in this particular case, like even the cubicles inside a room, you can have these kind of colored templates over there, that colored glasses, and that can actually harness the light which is from the artificial sources and also the diffused sunlight. So that offers a lot of possibilities, and particularly the indoor photovoltaic arena is really taking a strength globally in this sector. Yeah.
Thank you, Dr. Suraj. Now we have to ask a very important question from the end user perspective. We have the architect Anand Sabu, Director Megajoules and founder Sakayo Design Private Limited. So Anand, could you comment on from the architectural perspective on the challenges for BIPV implementation, supply chain for BIPV products, need for customized BIPV solutions and aesthetic value, and also with a focus on the multifunctionality, as you are mentioning in your presentation. Over to you.
Yeah, thank you. Here as an architect, when I look at solar, which is there, and when I look at BIPV, it gives a specific market segment. When a customer looks at and we try to promote it much more at our end, one of the most important thing is to generate a net zero, a decentralized system, which is there. At that point of time, BIPV gets much more focused viewpoint, which is there. And when we look at in our experience of 8 years, as we are practicing into consulting aspects, specifically into BIPV systems, which are there, and at present, the projects which are come across and projects which are under pipeline, like Asian Paints, a pharmaceutical company, which is there. So in that, we have to always convince a client about waiting for the right technology and what budget he is putting it across. At this point of time, and how other technologies which are coming and their aesthetics which they would review, they would like to have into their building, we have to look at that this is the aesthetics which could be delivered to you. For an example, in the Asian Paints building, we are not looking at monocrystalline systems, and its projected time where the specific cost at that point of time which they have budgeted is in 2024, when the complete building will be ready, and that point of time the BIPV systems will be required and the installation will happen. So there is a timeline where when you conceptualize the idea and the execution which happens. And one of the most important thing which is there is to make them clear about the product which is going to come across and the lapse in time. What we have evolved whenever we look at a supplier, we have done a 2 kilowatt system, which is a which is a standalone system, and a 200 kilowatt system, which is there. So whenever we go to a supplier who is going to supply, there is a certain benchmark which we have evolved in the journey, that if it is a 50 kilowatt BIPV systems, people or the supplier are interested to do it. But when it becomes a 5 kilowatt systems, so you are looking at a multi-storied building only, which is 10 floor or 20 floors above, and then someone would be interested to do that sort of BIPV installation at your site. You know, when it is a 5 kilowatt system, it is the understanding of cost or the ROI, which we look at a rooftop system, it goes completely to the toss. So in the process of what we have understood is we benchmark our cost system or the budgeting, that if some client is much more looking forward that I want to do an experiment, so we say there will be no ROI to your building. It will be one of its own kind and other things. But when there's ROI calculations happen, we have created our benchmarks that if it is 50 kilowatts, 100 kilowatts, and what sort of parameters has to be kept forward and how much production it could do. So it because when we look at smaller systems which are experimental and other parts, then it is if I look at imagination, I will not. I just hard to get a supplier, because supplier also looks for its profits and doability. So that's where I look at the excitement of experimentation, which I look into the aspect of we doing. It fades out at that sort of cost parameters. And of course, when we look at 50 kilowatts as a benchmark, there is also all the panels has to be certified. Then the economics of that panels also stays into that domain, that your certification cost also reduces per kilowatt. You know, if we are customizing a panel that has to be certified, so the certification cost also goes to each and the panel segments which comes across. So that's where we have evaluated a benchmarks where certain scale of product only can be done into a BIPV systems, and certain couldn't be done. And so that's what we have to educate our end customers about it at this point, so they can use it in a right format, and the budgeting can be done rightly. And as the time lapse happens, so the innovative technologies can be also integrated, and at some point of time cost reduction can also help the client, or else a cost reduction can make him take a superior product at that point of time which is available. Yeah.
Thank you, Anand, for very brief and briefly sharing your experience. So, on the interest of time, now we have to conclude this section. In conclusion, I should say that it is a very enlightening discussion, receiving multi-perspective of BIPV sector of India through our respected panel members, briefly pointing out the important aspect of the discussion, such as requirement of exclusive testing, certification, as I said earlier, testbed facility and capacity building programs for BIPV sector is a major necessity for our country to improve and sustain the quality and standards of the product that is coming into our market currently. And need of research-oriented product development can cause a major leap forward for the country in the sector, as the possibility for photovoltaics integration in the buildings are huge. I again request those who are listening online to have a look at the different BIPV technology innovation that CSIR and SUBSI can offer in this front, and also the different innovative products from the industry exhibitors. Kindly have a look on this thing. So the major take-home message from the panel discussion is that we have the right ecosystem for BIPV sector as such. However, the need of green buildings and BIPV specific policies and regulations should be included in the coming years for improving the attractiveness among consumers. With this, I request Dr. Narayan Unni for the concluding remark and vote of thanks. Over to you, Dr. Narayan Unni.
Yeah, thank you, Adarsh. But before I conclude in 2-3 sentences this kind of a very informative session, I wanted to ask one question to Mr. Anand Sabu. After looking at your structures, very innovative structures for the BIPV solutions, I just wanted to ask, anytime have you tried coupling wind and solar together?
We had experimented once, but then the electronic collaboration between the solar and the wind, they have to be two different systems which comes together. So we have not tried it. We have experimented on to it, but it was not commissioned into a commercial sense. But we have an experimental model where we have used vertical turbine systems with the solar panels to do a small experiment at a I would say entrance of the factory system which was there, but it was an experimental system which we did, but then it didn't went into a commercial sort of location at that point.
Thank you. In fact, it reminded me of some activity by a CSIR lab, CSIR Indian Institute of Petroleum, IIP, as they have a biodiesel program. So there is a generator with IIP diesel, wind and solar together. So it's a hybrid model of energy generation. So that is where I will pass on the contacts to you. We can have a further discussions on that. Okay.
Thank you, sir. Thanks.
So thank you all. We have come to the end of very intensive, thought-provoking discussions in BIPV. So I don't know what to say as concluding remark, but at the same time, I see that there is a general consensus that we have to develop awareness among builders, architects, scientists, engineers in bringing about this technology further. There is no doubt about that. But at the same time, people like I recall what Abhishek was also saying, aesthetics should be conserved when you put in any design into building structures. But again, then that is also very personal aspect, right? Something which is looking good for one person may not look good for another person, but still on a consensus we can have some sort of a design for such structures which is widely accepted. There's no problem with that. So awareness is one thing, and to preserve the aesthetic aspects of the buildings is another thing. And then government support, regulations, whichever way it can be supported, that has to be supported. So that kind of a recommendation this meeting can actually put forward to government, that building integrated photovoltaic in whichever forums or whichever way government regulations can support the widespread dissemination of this activity, that we can request to the government. And also a lot of discussion about standards. So I think that is also generally agreed that whatever standards are accepted for photovoltaics in general, we all agree that it is not readily, it cannot be translated to standards of BIPV. But again, CSIR, as I mentioned, it is a national metro. We have a national metrology lab, and we need to continue our discussions in that direction. And I remember what my colleague Dr. Suraj Soman presented also. Indoor photovoltaic is another branch of building integrated photovoltaic, but not outside, within the building. Even BIPV for indoor photovoltaic also do not have a globally accepted standard. So these are the challenges before us, where we can define certain standards, and then we continue to work on developing prototypes or models which will meet the standards which are subsequently approved. So I think that is the take-home message of this. There's a lot of potential in this area, and definitely it is a need of the hour. And we all, when you look at the industry participants and the CSIR labs participation, and all I see that there's a lot of potential in CSIR as well as in industry. Only thing is to find a synergy between these two streams and to come up with some platform, some proposal, some consortium, so that we can get along with this work further. Thank you. And now let me move on to my duty of offering the vote of thanks. Others?
Yeah.
Vote of thanks is on me or you?
Yeah, you can proceed.
Hello.
They started, we didn't
Hello.
look at the program schedule. So anyway, we have come to the end of this very interesting session. So I would like to thank each and every person involved in the organization of this particular event. So as I mentioned in the beginning, iConnect events are organized as part of Azadi Ka Amrit Mahotsav, which is marking 75th anniversary of Indian independence. So the government mechanism is behind us. The Ministry of Science and Technology and Ministry of Earth Science together came up with this idea of having these 75 events with interaction industries. So special thanks are due to Council of Scientific and Industrial Research and entire CSIR family, including headquarters and Technology Mission Directorate and all labs for consistent support and guidance for organizing this event. On behalf of the event coordinators, I myself am a coordinator. I would like to thank Dr. Ashish Lele, Director CSIR NIST and the CSIR NCL, for his inaugural remarks and guidance during the entire organizational process. Thank you, sir. And let me take this opportunity to sincerely thank all our industry speakers, esteemed panelists, and also I would like to place on record a sincere gratitude to Dr. Bipv Malhotra, Head Technology Management Director at CSIR, and also Devendra Singh, Principal Scientist, who supported us at every juncture in organizing this program, and the whole team for organizational support and coordination. We thank the NFDC team for the excellent arrangement regarding the online platform, exhibition booth, and all those kind of support. This event required a lot of support from our own institute. I would like to thank our former director, Dr. Ray Ajaykush, and also Dr. Savitri, Chief Scientist, CSN NIST, for all the advice, support, guidance whenever and wherever required, and my colleague Dr. Adarsh Ashok, who has actually took the load of organizing this event. He almost single-handedly invited people and managed the event. So big thank you to Adarsh also from CSIR. And all other people individually, I thank all the people, and I think I need to also thank our partners in this event from SOPSI. We had very active participation. The director of ISAC SOPSI, Dr. Roman Rudel, gave the inaugural address. So let me thank Professor Rudel also, and Pierlo Gibonovo, Head of Advanced Building Skin Team, Mr. Paolo Cotti, Researcher, Advanced Building Skin Team, BIP Center. The industry participants like architect Anand Sabu, Mr. Pashupati Gopalan, Mr. Jido Joseph, and representatives from ANART, Mr. Pramod. Then again, BIPV industry representatives from Topsun, Standardization, Elias Robina, and yes. So I hope I didn't miss anyone. And also we had colleagues from CSIR labs like Veena Chaudhary from CBRI and Tabish Alam from CBRI. And I think I should thank our student participant, Mr. Animesh MR, also for doing all the groundwork for arranging this conference. If I missed anybody, it is not intentional. Kindly excuse me. I had the list of people attended this conference, but in the last minute, I think some other participants from industry also came on board. So let me thank all the participants who expressed their views on building integrated photovoltaics, and also all the CSIR family members and the general public who attended this event through online platforms like Google, YouTube, and Facebook and all. So let me thank all of them for making this program a grand success. Thank you. Thank you very much.
Thank you.
So I think we come to
everyone. Yeah, we can. Bye.
Thank you. Thank you.
Everyone, thanks.
Thanks.
Thank you.